Okay, today we're going to be dealing with understanding area and perimeter, which most of you are pretty good with. But I want you to just answer those two questions right there, okay, after you get the top part of your notes done. And while you're doing that, I'm going to be handing out some of your work we'll be going through today. Let's go ahead and talk about area and perimeter. Okay, notice I decorated our note page here with squares and rectangles. It's actually because this is done in Excel and I just forgot to hide them in that. But it really goes along with the theme of area and perimeter, I think. So how do you find perimeter of a polygon? Grace? Yeah, perimeter just means the distance around. You're adding up all the sides. Find the perimeter of a polygon, add up the distance around it. Okay? I used to, back when I taught in a portable, back when I taught at the middle school in LSMS for a long time, if students messed up distance or area and perimeter, they just said, okay, you got to go march around the portable once. That's the perimeter of the portable. You don't get to be in this area right now. You get to go march around the perimeter. And they go walk around the perimeter. Okay? Perimeter is distance around. Area is inside. Okay? What's the formula for area of a square? Yeah. Yeah, area of a square, we can think of it a few different ways. A equals LW, but in a square, yeah? S squared? Yeah, in a square, all sides are equal, so the length and width are the same. In fact, in a square, we don't call it a length and a width. We actually call it a S, which means side. Okay, so all these sides are equal, so we just say this is S times S, or S squared. Okay, that's another way. But L times W works as well. Okay, but you'll see S squared a lot as well. All right. Postulate 5-2. I'm not going to make you get a book and read that. We're just going to kind of go through it. Okay? In fact, let me put it up there for you because I don't want us to have to dig out books. But if two figures are congruent, while I'm getting to that, why don't you guys tell your neighbor what you think it is? If two figures are congruent. We talked about congruence.
Is there perimeter?
See if you got it. If two figures are congruent, then their
areas are equal.
Areas are equal. Okay? If two figures are congruent, then their areas are equal. And the other postulate, postulate 5-3, says the area of a region is the sum of its overlapping parts. Of its non-overlapping parts, excuse me. Okay, so if you have a region that's kind of weird looking, say like this guy right here, the area of it is, you could say, well, it's this rectangle plus this rectangle plus this rectangle plus the area of this rectangle. Okay, it's the sum of its non-overlapping parts. Or some people would look at it and go, well, it's this square plus the area of this square plus the area of this square plus the area of that square. Okay? There's a lot of this you've done before and you shouldn't write in books, even if they are 20 years old. Okay? Just means they've been through a lot, man. I know. All right. Very good. I know. You got to go stand on your head and drink water. Yes. How do you find the area of a rectangle? Go ahead and tell your neighbor.
Oh.
Cameron, what do you got? Yeah, Cameron gave us that earlier. It's area equals length times width, right? Okay. All right, nothing majorly new, but we're going to review. Okay. Here we go. Please take a look at the example side. I want you to work with your partner. Try to complete number 1, please. Up here. Okay, now finding the perimeter of this generally is pretty easy when you're going from here to here. You know, -2 to 1 gives me a length of 1, 2, 3, right? And then from -1 all the way up to 3 gives me a length of 4. Okay? So 3, 4. Now some of you that know your Pythagorean Theorem, remember Pythagorean Theorem, a squared plus b squared equals c squared. If this is a and this is b, this is length c. Or if you want to use the distance formula, it's the same idea. I personally just like using the Pythagorean Theorem. If that's a, that's 3 squared. If that's b, we make that now 4 squared. We substitute that in for a. We substitute that in for b. And c squared, so that gives me 9 plus 16 equals c squared, or 25 equals c squared. Square root of 25 is 5. This is 5. Now that means that perimeter is 3 plus 4 plus 5, or a grand total of 12 uns. Okay? Also known as units. Okay? 12 units. Now, this is called a Pythagorean triple. Those of you here this summer, we talked about Pythagorean triples. 3, 4, 5. 3, 4, 5. If you ever see a right triangle, we know this is right because this has a slope of undefined and 0. If you ever have a right triangle and you know one side's 3, the other's 4, that one's 5. Or if one side's 6, the other's 8, that one's 6, 8,
6, 8, 10.
10. You double it. Or 9, 12, 15. Okay? Pythagorean triples. Some of you are going, I don't care. Well, dude, you will care. Promise. Some of you are like, man, this is the best stuff ever. All right. Why don't you take a look at number 4, please? Number 4. Find the area of the given rectangle, of each rectangle given the base and the height. And I've given you a little note on the bottom there. When there are differing units of measure, convert the bigger to the smaller. So notice, this would be easy in a rectangle using our formula A equals L times W. This would be much easier if these units were the same. Now, some of you not paying attention, you won't even realize they're different. You're just going to go, I'm going to go 9 times 2, it's 18. Done. Okay? But your units are wrong. Convert the bigger to the smaller. So the bigger units, feet or inches? Feet. Okay? How many inches is 2 feet? 24, right? 2 feet. Okay? Times 12 inches per foot. Okay? That gives me 24 inches. Most of you will just say it's 24. Well, if that's 24 and that's 9, that means now length times width is the same as base times height, by the way. Yeah. Is it 216? I haven't actually done it yet. Okay. I was just going to put in the numbers here. Did you do it in your head? Yeah? Nice. 9 times 20 is 180. 9 times 4 is 36. 180 plus 36 is?
216.
Is that right?
Yeah. Inches squared.
All right. Good, man. 216 inches squared. Okay. Give number 5 a go, please. Actually, I think you can do that one. Do that one. Number 6. We only have time for one more. So. Huh? I don't know. We'll find out after number 6. Okay, what's smaller, centimeter or meter? Centimeter. So we always want to convert the bigger to the smaller. So how many centimeters are in 1 meter? 100. So 3 meters, 3 times 100 is 300 centimeters. Those are the same measure. They're worth the same value. It's like 4 quarters equaling $1. Okay, same value. So if I put my base in as 300, I put my height in as 200. 3 times 2 is 6 with 4 zeros. 60,000 centimeters squared. Is that what you got, Julie? Yeah. How many got it?
Yeah.
Your assignment. Write it down. Example 1 through 9 plus 13 and 18. Mixed 4 through 6 plus 17, 18, and 19.
4, 17.
17 through 19 on the mix.
When you have on number 4.